All right, before the break, we were looking at a basic idea of what software was, running some notes about vocabulary that will hopefully be useful for you on your way through education. It's an active subject we learn by doing. So here really shortly, we started into an example, just a follow along example thing to do. First off, though, I want to put a couple more words up here, the categories of software. I'm marking these all right. There's different ways we can categorize our software, and these are some important words to know because they behave differently. So first off would be interpreted. Which I always have to spell that word very, very slowly. Interpreted versus compiled. So before the break, we saw that high-level abstraction that makes it something easier for humans to work with. We use keywords that we would recognize, we would meaningfully recognize, and switch things to the order humans need them in. Like if we're going to add two numbers, we put the plus sign in the middle, not out front. Little things like that. But we need to that needs translated from that high-level abstraction down to the machine level. And these are the two big ways we would do that. So interpreted is line by line. And compiled is the entire file at once. So in pictures, we write our computer code in text files. So we'll have lines of instructions there. I'll just kind of do it like that. So here's our first instruction, like set up a variable, put a number in there, set up another variable, put a one in there. We'll talk about what a variable is here shortly. A place to hold things, I guess a summary on it. We have all these different instructions. So in an interpreter, we grab those one at a time. We come over here, we grab line one, we turn that into something the machine can understand. There's several different languages. Could go to something called bytecode, which is sort of in the middle. Could go all the way to assembly language, or we could go all the way to machine language. I'm just going to write out a bunch of ones and zeros. 0, 0, whatever it would be. But we take this instruction and turn that into something the machine would recognize. So I'm going to write the machine language here. Then we come back and we grab instruction number 2 and turn that into something the machine recognizes. And instruction number 3, and I think you all see where this pattern's going. Right? One line, we grab them one line at a time. 1, 0, 1, 0, 1, 0. And in a compiled language, we have a similar starting point. We'll have a text file with all those instructions in them. But we grab the whole file at once. We grab all of them and make a file of something the machine would recognize. So then we have the whole thing. There's subtle differences depending on what we're doing. They have different advantages and disadvantages, basically. So the interpreted language, if we have an error on like line 4, then lines 1, 2, and 3 are going to run fine because the computer hasn't looked ahead to see that line 4 has an error on it. So it would run partway through and then it would crash. The compiled one, if we had an error on line 4, we could never run it to begin with because we translated all the machine language at once. Order matters here. So if we do something way down here on like line 6 or 7, or when you have to put in the picture, we can't ask for that on line 2 because the computer doesn't know about it yet. But over here, we do something here, and we could ask for it here because by the time it gets over here, the order's been swapped around, but these bits know about these bits down here. So we can just jump down there and grab them. They already exist. So the order doesn't matter as much here. It still matters, but not as strict as it is over here where we start at the beginning and just work through. That's how we get from that abstraction into something the machine can understand. A couple other words that are going to be important. Imperative. Versus declarative. So imperative is explain how to. A declarative is ask for pre-built versions. So over here, these instructions that we're putting together, if we have to actually explain to the machine what to do, like there's going to be input coming from the keyboard, take that input, put it in RAM, wait for the next input from the keyboard, put that in RAM. When the input from the keyboard is the enter key, take all those things you just put in RAM and throw it back to the screen. And how to carry out the task. Declarative, that part's already been done. All that how to has already been put in there and it's just been assigned for a few keywords for those repetitive tasks we're going to do over and over again. And we just ask for those. So imperative, that's what we normally think of programming languages. So C++, Python, Rust, Java. Mojo just came out this summer, but it's an update on Python. Runs 4,000 times faster. That was the bigger problem with Python was it's so much slower than our other languages. So this guy that's already made several languages is really, really good at it. One of the languages he wrote, as soon as Apple saw it, they discarded all their old plans and said only stuff written in his language Swift is allowed to run on an Apple now. So he's really, really good at it, but he took on the challenge of making that faster because everything about this is made to be easier for the human, but that makes it harder for the machine, slows everything down. 4,000 times faster is still considerably slower than everything else in this list I put here, but it's not as slow as it was. And we're talking about nano and milliseconds, right? We're talking slower at computer speeds. So it's got to be a lot before a human even notices. Right? We can't tell the difference between 300 milliseconds and 400 milliseconds. They're both pretty quick from our perspective. But they add up. If we need to do a million things, it takes 100 milliseconds longer to do each one of those things, then we really start noticing it. This would be things, SQL, HTML. I'm going to write low code. I'll put that in parentheses. It's not actually a language. That's another category. Instead of the text file, we drag our mouse around and put pictures together. So oftentimes flowcharts, but you'll probably see flowcharts anyway through class. The more serious ones use activity diagrams and timing diagrams. But we drag our mouse around to put together a picture, and then that picture is the diagram that represents what we want the program to do. Typos are bad enough in English, right? If we're typing in the language we know, we're going to make typos constantly. If we're trying to type in the language the computer knows, it's a little bit different than our own. Typos become a big problem, so it's nice to just drag your mouse around and put the picture together. In our modern world, there's things, people have put together things where the machine just listens to the programmers sitting around talking about what they want to make. And the machine makes it all just listening in another meeting. So some of the stuff with AI is, computers are better at writing the code than we are. ChatGPT is great at writing code. And actually there was one of the replacements for that one, built by the same OpenAI, the same people, is specifically for writing code. lie part in that AI is just not true at all. Those things have no intelligence whatsoever. They do a specific thing. They're not intelligent, so they can't put together an algorithm. An algorithm is the steps necessary to carry out a task. So if a human who is intelligent can put together the order that steps need taken in, the AI, the chatbots are way better at writing the code, but they can't come up with the algorithm. They can't figure out the process on their own. But once a human can tell them what the process is, they will spit out the code to carry out that process almost immediately. Actually, most chatbots, if you've ever seen them, they actually put a delay in there because it's quick as anything else on a computer, but they put a delay in there and like animate it so it looks like it's coming slowly, just because people respond better to it. So a couple categories, and there's lots of overlap. So yeah, HTML is a compiled declarative language, and SQL is a interpreted declarative language. So there's overlap between these categories, obviously. Python is an interpreted imperative language. What's the next category in here? Scripting and programming. The way we would normally use those words versus encoding. This one's to perform actions. Kind of the imperative thing, like how to perform those actions or ask for the pre-built actions we want in a certain order. Whereas encoding is like formatting. How do we want to format our data so the computer can work with it? There's several options, or also for very common tasks, the things that we're going to do over and over again. Adjust how a human works with the data to between how a human needs the data and how a computer works with the data. That transition spot, software developers fall in there. It's actually one of the most a very, very common thing for programmers. So like at Humana here in Louisville, there's that 40-floor office building full of people. Quite a few of those floors, maybe a dozen floors or so, are filled with software developers. Not making new software, they're reformatting the data, going back and forth between the database and the human and other existing software so that we can work with that data, going back and forth, finding new ways to work with it. I guess there's some overlap there with those floors at Humana, but that would be a thing that shows up a lot. Small programs to automate the process, right? Humana has 100 million customers, so we wouldn't want to go through and do it by hand. So we have to automate all that formatting process and get it ready to work with somewhere else. HTML is a particular format. We use them. ML stands for markup language. That's one of your assignments this week. We add tags in so the computer can identify certain things. We want to have a bunch of words we want to put on a web page, but we don't want to put them there just in black and white. Looks kind of boring, right? So we format it different. We add little bits of little tags around. So we have the word we want to show, and we'll use what we call tags. We put an angle bracket before, so say a P stands for paragraph there. We just want this as a normal paragraph tag. So put a P before it and a P after it. Once you're all have to take a class where you type those in to get used to them, but in the long run, we would automate the process of adding those tags in because it gets a little tedious to type it. If we look at this, it says our data starts here, and we can add extra little things in here. So metadata, data about our actual data. So start here look at the metadata, the actual data can end here, which happens to be the same order the CPU works in. So it's a better format for feeding through there, and it's still human readable, easy for a human to work with. One of your assignments is add those tags in there to kind of get a view of what markup languages are, but that sort of formatting. And then the computer knows what to do with them. HTML in particular becomes a tree, which the computer turns into a heap, which is the fastest way the computer can go through data. And no matter how big the data is, the speed does not decrease as we add more data, which takes a lot of extra work from a human, but most of that extra work is already built into the browser. That's why there's only a couple of browsers out there, because it takes a lot of work from some of the best programmers in the world to do all that background stuff so that we can take this format and immediately turn it into the best way for a computer to work with. So no matter how much data we transmit across the internet, it's ready to go for that. We'll see that in our example. So different categories, some keywords to get started on. Again, sort of a vocabulary class, introducing this stuff. Look at the keywords in there. Yeah, we combine a few keywords and those operations we know to put together instructions. So somehow or another, we are telling a machine what to do. No matter where you're heading in IT, you're going to be telling a machine what to do. And that's basically what software development is. So we get some practice with that here. And it's what we usually refer to as programming. All the stuff kind of builds up. Look at that. It's also about problem solving. I raised the example from beforehand, but we had some problem we wanted to solve. And those examples were solving that problem. We don't need to dive into it too deeply here, but just to read off this list. It has been mathematically proven that we only need 4 types of tools to solve any problem. Well, maybe we're right on the board. It's okay if I erase this part over here. Yeah, that's some keyword stuff that you're gonna hear over and over and over again. And hopefully you notice which ones I just quickly described and which ones I took the time to draw a picture of to give you some indication of how much you're going to hear each particular set over and over and over again. So something called the 4 constructs. This isn't just a computer thing. Types of tools. To solve any problem. So the first one is we need some sort of a sequential tool. We need an order to go in. Things have a sequence, an order. The steps to solve the problem have to happen in a particular sequence. Selection. We need to make choices along the way. Reiteration or repetition. In the software development classes, I usually distinguish between those 2 very precisely. The way I do it is repetition is an exact repeat. Sometimes we want that to happen like on a web page where we want the animations to just loop over and over and over and over again. It's repeating, it's the exact same thing. Reiteration is repetition with variance. So like mowing the yard. You get out, stand behind the push mower and you push that along and mow a strip of the grass. Well, repetition would be going back to the beginning and mowing the same strip of grass. It never varies, so you're never going to finish your yard that way. Repeat with a little bit of variance, like grabbing the push mower, going down, and then we turn around and move over and mow the next strip and have a little bit of variance in that process we're carrying out so that we eventually finish mowing the grass. So that English language gets complicated, but that repetition with variance is sort of important. Or sometimes just exact repetition is the important part. animated logo will to loop over and over again the whole time somebody's on our webpage. The last one isn't as commonly used as a word, but invocation means we need a way to jump out of our sequence and get right back to where we were. So we're going through the steps, we carry out step 1, step 2, step 3, oh, I forgot something, go do something else, then come right back to where we were and jump to step 4. We don't have to go back to the beginning and start over. That's the types of tools needed to solve any problem. The famous one, world peace, will only evolve those things, just people haven't figured out the right order, the right choices to make along the way. But it's those categories, those types of things. If you're hanging out with your friends, watching TV, commercial comes on or something, or pause it briefly, and somebody gets up and goes to the kitchen to grab everybody drinks. We still use this, right? There's a certain sequence. You grab the cups out of the cabinet and open the bottle of soda and fill the cups. It wouldn't work in the wrong sequence. Wouldn't do any good to open the bottle of soda and start pouring that and then get your cups out. Choices along the way. Maybe somebody wants water, somebody else wants Sprite, somebody else wants Mountain Dew, so you're choosing what to put in each cup. Some of them with ice, some of them without ice. You're filling a whole bunch of cups up for your friends with different sodas. So kind of repeating that similar process, all the cups are filled. Maybe halfway through, somebody else in the room, like, oh, wait, I don't need a soda. Give me a water instead. So you have to jump out of your sequence, make any adjustment to come right back to where you were. Those are the types of tools needed to solve any problem. And we have these in programming languages. So sequence goes with our text file. The computer's going to run them in order. Line 1, line 2, line 3. It's going to run through the order we put the instructions in. We have tools to make selections, make choices. Have tools built into the language to repeat things. There's actually something they can do. Recursion, which is a controlled feedback loop. Machines do that on their own. In my world, I assume everybody has experienced audio feedback. If not, I could unmute the Zoom call right now and could experience it in the classroom. But I think everybody knows what audio feedback is, right? The output from the speaker goes into the microphone, it goes into the input, which then gets amplified, comes back out the speaker, and we get that loop. Usually an annoying for audio feedback, but some musicians learn to control it, and it was just another note their instrument played. Jimi Hendrix and Tom Morello are probably the two most famous for being able to control the feedback really, really good. Tom Morello would unplug his guitar and get feedback. As just a note that came out of it. So when we control that feedback loop, that's the way that's built in, but it's really, really hard. Right? Kind of like audio feedback. If you list out the musicians and you're really, really good at that, you're going to list off some of the best musicians humans know about, and it gets really, really hard to build in. So there's better tools built in. It's kind of a hard thing, but it's what's natural to the machine. It's also hard because not every problem can be worked into a recursive feedback loop. So sometimes we have to change the problem we're trying to solve into one that can be done recursively and solve that, and then translate the solution back into the solution to our original problem. So it gets very, very difficult. So almost all of our programming languages have what's called loops worked in that make it easier to repeat things. In general, we write text files with some pre-built structures for that to solve problems. Lots of places that we can work on things. Typically, well, really we just need a text editor, but as text editors get fancier, we start adding different titles on them, including what we call IDE, for Integrated Development Environment. So a place to write text with lots of extra tools that might be useful for us. Things that will automatically compile the code and run it. So instead of just a text file, and then we go over to, say, PowerShell and run it through a compiler and then tell the computer to start that program. That part is built into just a green button that comes in usually a triangle shape, like a normal play button. that we're used to seeing. So little tools like that built in. One I'm going to recommend here, we'll work on both of your assignments. I guess currently people are calling it Replit. replit.com. If you would navigate to that site, both of the homework assignments this week can be carried out here. This is an online IDE, a cloud-based IDE. It's very popular. It was originally repl.it. Actually, there was something else before that. So it was originally made by Czechoslovakians. So it was repl.co.it. It was made by Czechoslovakians who apparently pronounced that REPL as Ripple. That's apparently a word in Czechoslovakia. I was pronouncing that wrong for years and heard that. I was like, oh, Ripple, that's a nice word for it. But then they stopped hosting it in Italy. So the .co.it didn't make sense anymore, but they wanted to keep the .it because that does make sense. Most of the world, even non-English speaking world, still uses IT for information technology. So they wanted to keep that part, so it was repl.it for a long time. And that's where it started gaining popularity. And people came to know it. And then a couple of years ago, they switched it to replit.com. Finally switched to a normal web address. So, lots of different ways to pronounce that. I think lately, I recently heard somebody say Replit. That seems like a nice way to pronounce it. That flows off the tongue easily. However you want to pronounce it, but that site, which I should sign out of here. I'm signed in. Where's my profile? So when you first go here, you'll see fancy stuff on the page, fancy animations. It comes with we won't get there in this class, but it has the AI chatbots for writing your code. So you just have to tell it what you want to do, and then the computer's better at writing code than you are. Ghostwriters is what they call them. So I guess what they're used for most often is people start writing code, and the ghostwriter will give them suggestions, improvement, tell them how to improve the code and stuff. That currently still seems to be more popular, but it will write all the code for you. You just can't come up with an algorithm. Has the normal cloud stuff. They keep changing their animations, so multiple people can work on it together, kind of like Google Docs. I think most people have seen that in Google Docs, right? Y'all can log on to the same document and edit it together, and everybody's cursor shows up in a different color, has a chat room, share buttons, all of that stuff. Down here, they list out the most popular programming languages, but they just ran out of them. It knows way more programming languages than this. They just started with the most started listing out the most popular. This list changes dynamically. So this is what's most popular on there today. Tomorrow you will see something. Actually, tomorrow you will probably see the same list because it does change slowly, but 6 months from now you would see something different. It's a good thing you might want to set up an account for it. It's free to set up an account. I've never had any trouble with spam or anything like that. So it's a place to write code. So it's an IDE, the integrated development environment, but they take it even further. There's templates, so you can start with stuff that's already half written already. Restoring. They have jobs on here. So if you're heading down a software development pathway and you need to gain some experience, you can go on here, and there are small jobs, which are like 1 or 2 days. They expect people to do in 1 or 2 days. And they kind of try to promote that for students so that when you graduate, you have a few things to put on your resume already. There's social media stuff on here. It's that's really been growing over the last year because people are getting really sick of the other social media ones. It's about time for a big change there. The social media presence here has been growing. So when you set up an account, you can just meet other programmers and stuff. This Learn tab's nice. You're here learning, and they have tutorials built in. Lots of things you can click around, see different things. Create ripple, however you want to pronounce it. I guess a lot of Americans say ripple, but that original name, which is apparently Czechoslovakian for ripple, still means ripple in the water, same thing and stuff, but they spell it different than English. Still a Germanic language, so it has the same roots as English, but the other side of Europe. Well, you would just choose a language. So your assignments this week are Python and HTML. So if you just put in a little search bar here, it does know both languages. So you can do both of them here. And if you do so, you don't have to download and re-upload the files. There's a share button, so you can just send me the share link like you would do on a Google document. So yeah, instead of downloading and then uploading, here's the link where you can go get it on the internet yourself. That was the core idea that really made the internet take off. Instead of sending you the data, how about I just tell you where to go get the data? That's usually a lot less information to send, so it transmits quicker. So just create a new one. Python is one of the assignments. This language was created in Christmas break over 1989. Great story to it. He could not get out of a family event, so he made up a work project so he could get out of talking to his family. And by the time he got back to work, he realized he was kind of onto something great. Downside was obviously he still has the same family, and what he created as an excuse to not talk to them has become the most popular programming language in the world. So surely they know about it by now. It's made him very, very rich, I guess. I suppose. But examples of generated code with a ghostwriter. So it's a link right there in our text editor to get those modern features. It connects to GitHub. We'll look at that briefly on Thursday. Again, I'm teaching an advanced class on that. That's what my evening class is this semester. So it kept showing up as a single lesson in class, which really ended up being the same lesson over and over again. And nobody ever got the full picture. So last year, I took that to the curriculum committee. He's like, I want to do a whole class on this. So this summer I'm doing the trial run on it before I take all the paperwork on that. But that's a different thing. We'll look at that. See down here, there's some telemetry. So we can pull up the numbers on how much CPU, RAM, storage we're using. It's on a cloud, so this is the CPU of the server it's running on, not a local one. Different tools, lots and lots of things built in, but we're going to write some code. So Python, there were special symbols that were used a lot. Curly braces to combine things, like sets of instructions we wanted to go together, and we set up blocks. And curly braces kind of set up, right? The opening one, and then somewhere later we'll have that closing one. And if there's more in between there, it's easy in the opening and closing ones to keep track of them. So common typos, so we may Python anyone to get rid of those. We also have semicolons, which end of instruction is how we're going to think about it. That's the symbol that means end of instruction. We type a line of code, end of instruction. There's a technicality that the computer actually reads that backwards, so the semicolon actually means next. But the way we type it in the file, it's much more useful for us to think end of instruction. That technicality that where the computer is backwards from us and the computer think backwards. So to the computer, it means next instruction. To us, it means end of instruction because it goes at the end of the line. A very common thing to miss, and I'll put that on there. You can see it. If we're staring at this text file looking for the typo, that's a really, really easy one to not see. So he wanted to get rid of those. And some other steps that made it easier. So in Python, our next instruction is just the next line. Humans split that up. The way we think about it, splits up lines by lines. And to block things together, we just indent, which is kind of what comes naturally out of a lot of people. I guess there's a trade-off there because looking for a missing curly brace is nothing like looking for a missing white space. Or extra is worse. Looking for the extra curly brace is nothing compared to looking for the extra white space. That one gets to be a headache. But usually it goes okay. That only happens occasionally. So first thing we need is we need some data to work with, something to store. So that's what we call a variable in programming. It's different than a variable in math class. A variable in math class is an unknown. That's the thing we're trying to figure out is we don't know. We know exactly what a variable is in programming. A variable is a named location in memory. So the computer, if we say we want to hold on to the number 3 for us, the computer is like, okay, it's going to stick that in RAM somewhere. So like, okay, that's in 3 is a 8-bit integer that starts at bit 43,217 in RAM. Computer has no trouble keeping track of that, but a human never will, right? We need an internal reference. I like to think about a neighborhood. If you're talking to your neighbors, you can use internal references, like say things like the Joneses house over there, that house that used to have green shadows, and your neighbors know exactly who you're talking about, what you're talking about. But if somebody's like coming in from California and they're lost, telling them the Joneses house is going to be helpful. So they don't know who the Joneses are. They're lost halfway across the country from where they know, from the neighborhood they know, or the other one I just said, the house that used to have green shutters. Your neighbors know which house you'll be talking about, but somebody from out of state, it couldn't get more useless than what color it used to be painted. So we need that external reference, something the human, because we're external to the machine, can remember. That's what a variable is. So we make up a name. So in math class, it was always X's and Y's. But that's not a very helpful name, right? We're not restricted on characters, so we can give it something meaningful. So first number, our restrictions are we have to start with a letter and no spaces. Can't start with a number, I start with a letter. And for now, for this class, I'm going to go ahead and say no special characters. There are some special characters that are allowed, but that varies language to language. So for starting off, let's just say no special characters. Maybe an underscore. Because first number is meaningful. We can't have a space though. So this is no good. Underscores are common. This is what we call snake case. Underscore, first number is assigned the value 3. So first underscore number, and we just replace that space with a little symbol there. Other than the underscore, let's try to avoid special characters. Camel case is very popular where we just jam the words together, and each new word starts with a capital letter. And the first one's lowercase. All these things have names. If we make the first letter, do the same thing, but make the very first letter capital, that's called Pascal case. Different names for them. You don't necessarily need to know them. I was just pointing out that all those different ways you write the letter, write your words have things. So I'm going to use camel case here. Just jam the words together, and every time we get to a new word in a big description of what that variable means, we'll add another capital letter to make it somewhat readable. So we can tell where the different words start, basically, as opposed to just jamming those two words together all lowercase. Or underscores, there's not really any restriction on how you write them for your assignment this week. So our first number, maybe a second number is 4. And then keywords like print out first number. So I run it. It sets up those things and then prints out what's stored in that first number. We can change it. First number equals whatever was stored in first number plus one more. It's called incrementing. A very common thing. Decrementing would be subtracting. When we run that, we originally stored 3, but then we took whatever was stored there, added to it, and stuck it back in the same variable. So it prints out one number bigger. And we build up our instructions that way. your homework has some step-by-step things to follow along. Those things I just mentioned, the selection structure, we can make choices. So it's like we're asking a question. Is our first number or second number bigger? We're asking the question, but we're not asking the computer, we're telling it. Can I zoom in here? Oh, there we go. Make that a little bigger on the screen. So we use the word if. So if first number is greater than second number. We have less than, equality, less than or equal to, since we don't have that symbol like we use in math class, we would do both of them. So like less equal or greater equal. We just use two of them. And then in Python, we indent them. So notice how each instruction gets its own line. So the line breaks take the place of that next instruction character, which makes it a lot easier for humans to work with. And when we want to block things together, like what do we do if this is true? Let's print out. We'll print the first, the quotation marks. The first is bigger. So quotation marks are kind of important there. That's a string of characters. A good way to think about it is we're telling the computer quotas on printing out these symbols exactly. It's not a variable. If there's no quotation marks, we're trying to refer to a variable. Meaningful name for a location in memory. And if there is quote marks, it's a string of characters, basically us telling the computer quotas on these symbols exactly. First number is bigger, and then print twice as much as the bigger one is, and then I'm going to put a comma and 2 times first number. Let me get this out of the way. Get rid of that line there. So the comma can separate it, print out this string, and then print out the result of this. So doing math, just like we saw on the board a moment ago, first number plus second number, I guess I have to do that here. Whoops, not there. I do that here. X is, X. Sum is first number plus second number. Difference is first number minus second number. We have all of our math operations. Comments are text that we put in here, the computer will ignore when it runs. Ultimately, those are used for things in classrooms, especially starting off. It's just text we put in there for like the little things to do. But if we ignore this text and only look at this text, there's nothing that stops us from going the other way. So in professional level, typically the comments are used to do two things in one text file. We ignore the Python code and read only the comments, or we ignore the comments and read only the Python code. Gives us a way to do two things in one file. But we're starting off here, just extra little like notes about what you're doing. A little description, adding or subtracting. Multiply is going to be your asterisk. Divide is the slash. 2 slashes is integer division, so we get a quotient and remainder. 1 slash is the floating point, like you're used to from a calculator, where you get the fractional part. Integer division, it just gives us the quotient. And we have another operation for the remainder, which is modulus. You may not have seen that. We divide and only keep the remainder. Divide and look at remainder. So if we only want the remainder, we'll use the modulus operation. So then it's one that exists. For this class, we'll probably just need multiply and divide. Exponents are 2 asterisks. We'll talk about logic. One of our logic operators is XOR. And it just so happens, by coincidence, it's not a repeatable pattern that works elsewhere. But XOR, exclusive OR, one or the other, but not both. If we do that on two binary integers, we get the same thing as if we would take an exponent. So that's a shortcut that works in most all of our programming languages. Is XOR on two integers happens to give us the same result as a binary. But it's just it's not necessarily a repeatable pattern that works elsewhere with any other base, or doesn't work with floating point numbers. So it's a coincidence sort of pattern that it works in two binary integers. But it does, so that's something we have. The XOR is just the caret. So it's one symbol instead of two, or sometimes we have to use keywords for exponents. So using a caret is a little bit shorter. So in general, bad form because it's just taking advantage of a coincidence. So we can do our math there. You see that, do our comparisons, and notice that it's indented to indicate what goes together. And when we're done with that part, we can bring it back out. Because if is going to be a yes or no question. So we're asking, is the first number bigger than the second number? But if the answer is yes, then we do all this stuff. But what if the answer is no? We probably want something we can do there as well. So we'll use the keyword else. So that's like otherwise. So if usually we formalize it by saying true and false if the condition is true, but it's a yes or no question. If the answer is yes, we do the first part. If the answer is no, we jump up here to the else part. So then we have some instructions for the computer to carry out whichever way the answer to that question falls. Because the computer itself can just figure out whether the answer is yes or no. It's one of them has to be bigger than the other. Otherwise, it means the second number is bigger, so we'll print the second is bigger. Oops. And the quote marks, I forgot the quote marks, I'm going to highlight all of them. And before the days of the mouse, to highlight things, we would use shift and the arrow key. So instead of dragging around, that's why we did there, shift and the arrows to get more control over it. Up and down, highlight lots of things. Page up, page down. Home and end are really useful. If you've never done much coding, you probably haven't used the home and end keys a whole lot, but planning on doing, if you're into IT, you're going to work in text files, and you're probably going to want to get used to your home and end keys. And then just hold shift to highlight. Another good one now. If you hold control and push the arrow, it moves word by word instead of character by character. It's a really useful shortcut. I'll highlight all those and then hit the quote mark, it automatically puts the closing quote mark. So things that come in pairs, parentheses, quotation marks, curly braces, square brackets, things that come in pairs. In modern text editors, we can just highlight it and hit the starting one, and it'll put the closing one in because it saves us a little bit of typing time. That would be a useful one because especially starting out, you're probably going to forget your quotation marks on outputs and things like that. So now we build up instructions for the computer to carry out. So when we run it, the second number is bigger, so everything checks out there, but we could change that. We saw databases last week. Maybe the 3 and 4 or 7 and 4 now weren't explicitly typed there. Those are actually things that are stored in a database. And the people in the database are not changed some stuff. So those numbers, when our software grabs them, they're different next time. So that's why we want to generalize everything. For starting off, we'll probably explicitly type numbers because it's not quite ready to connect to the database and pull our data dynamically. But when that changes, we get a different result depending on that output. Loops are kind of similar. I'll just show one of them. So we'll use this keyword while. So like if it's asking a question, yes or no. While does the same thing, but it asks the question over and over and over again. So maybe while first number is bigger than 0, print counting down. And then we want to take first number and change it so that we eventually get to the end. Because we're asking that question over. So while first number bigger than 0. Well, right now, first number is 7, so it's bigger than 0. So we can print counting down, and then we can take that and reassign it to whatever it was, -1. So that it changes. Now it's 6. So we can look again. First number bigger, 6 is bigger than 0. Go down, 5 is bigger than 0, 4 is bigger than 0, and we'll just keep changing it, and eventually we'll get down to 0, stop repeating it, and move on afterwards. And print, that's all for now. Here's some other little output. So first number is the bigger one. Does all that stuff, counts down. I guess we could add what it is in there and stuff, little changes, but get to the end, or we could switch back to what it originally was, switch that back to a 3. And when we run it, we get different output on both of them. The second number is bigger this time, and we only repeat 3 times. Invocation is a little bit more complicated, but that's 3 of those 4 problem-solving goals that I put up there. So we just put those together in different combinations. And invocation, we're going to write a bunch of. We'll have another file we jump over to, or another a set of instructions that we can ask for over and over and over again. I guess I'll show the syntax for that. I'll put it up at the top. We say define DEF, so we're going to define this thing that we want to ask for over and over again, this set of instructions. Usually the words function or method are the ones we use for those. And for now, we use them interchangeably. There's a technical difference between them, but y'all don't worry about the technical difference yet. You'll hear that in the software development class coming up. So we're going to define a function called do stuff. Put in some parentheses here and print doing stuff. And I'll just print a couple things. Doing stuff from a function. And then I'll just call that print instruction, which kind of is, that's a function that was already defined. Somebody already defined the instructions to put stuff out on the screen. And calling it with nothing is just going to print nothing. So basically an empty line. And then to ask for that, we just pass in that name we want. And then it has parentheses afterwards. So you can tell the store a value, a variable, it's just the words. The words with parentheses are store a set of instructions, so a function. And that's all 4 of those things. That's all the tools needed to solve any problem. It gets much more advanced. People have been building these tools for a long time, so there's a bunch of pre-built ones that we can combine into more complicated things, but so we do that, and then really we would do that kind of like the print method. We're using that, we're asking for it over and over and over again, right? So we would do that when we need to run those set of instructions over and over and over again. Probably something more interesting than printing the words doing stuff at the screen, but sort of the core concept. Your homework will just be following along example. You can do it here. And it's cloud thing, so we can share with other people, or down at the bottom. If you use this, Replit, replit.com, it'll be a useful one all your way through school, because you're periodically going to have to write small scripts and stuff, and it knows like every language. You can just send me the join link. So if I copy the join link and put that in, send that to y'all real quick. Let's go to the announcement. Another class, yes. Class example. Here's the quick example from class. So if anybody has set up an account, since I pointed that out at the beginning, what, half an hour ago or so, you should be able to join that. And well, right now there's a chat room and stuff. Whenever multiple people join, the little profile picture shows up here, and then a chat. We can go into a chat room and all those normal cloud features. I was sending that out so you have that example to refer back to. We can also do open another one. Your HTML can be done here as well. So HTML, CSS, and JavaScript for web pages. We actually use two different sites. Sorry, I don't know why I just said that. I might drift off somewhere. We use 3 different languages, and usually there's typically a 4th language running in conjunction. There's 3 languages we transmit to the client, and then there's a 4th language that runs on the server that doesn't make it to the other side of the internet, basically. So several languages put together, but there's these 3 languages. If I run this, there's already an example here. Notice it previews it in a web page instead of the output like we got for console. The output from HTML is going to be a web page, so they just went ahead and made a little preview thing there. We have the shell, so this is what the server is doing on the back end. We have access to that, doing that here. We can type all your HTML code here. So notice it has those words. I'll just re-edit this a little bit. I'll come over here, and instead of a paragraph, well, that didn't. I'm going to put H1. If I can type correctly, and then afterwards I'll type /H1. Predictive text is trying to finish that out for me, and it wasn't cooperating. Actually, it would have worked for that thing you showed a moment ago, where I highlight those words and I can put the stuff before it. Oh, not allowed. Never mind. I'll just type it in there. So we add these little tags. This is a level 1 header. That's our biggest, boldest type of header. There's up to level 6. So if we run that, that's that formatting thing earlier. We told the computer what type of data this is. This is level 1 header, so the biggest, boldest one. There's 6 levels of headers, so we can go down to H6. Which bold is another thing. Getting in software development, you're probably used to things like Microsoft Word, where there's a bold button. There are 900 levels of bold. So we have lots and lots and lots of control over bold. If we use words, there's bold, bolder, and boldest are in there as well. So programmers usually stick with those 4, but then we have, there's 800 levels. There's 100 to 900 are the numbers we can put in to say how bold something is. Most people don't realize that before doing any software development. It looks confusing at first, but there's more bold than is available in the one button on Microsoft Word. We can make this a paragraph, P, and then start the paragraph sort of data here, and our data is just these words. In the paragraph sort of data here, we run that. There's just the basic format for it. One of our most common is the anchor tag. This is that thing we were talking about earlier. Back in the day, RAM was a precious commodity. We didn't want to waste RAM on computer experts, so things were abbreviated. I first saw markup languages before the internet, but there was a time the mid to the late 80s, everything was on cathode ray tubes and not even nice ones that eventually had a lot of colors and stuff. But our printers could do way more than our screens could. So we needed ways to indicate to the computer what to tell the printer. The screen could only show one font, could only show the very basic lettering. It didn't even have different fonts, but the printer knew about different fonts. The computer, the monitor only had one color, either bright green or white, but the printer knew about lots of colors. So we would use tags in there, like a Word document, we throw in tags, say print this red, print this make this part italic, and indicate things that way. But it's abbreviated, and when the internet, late 80s, that was when they kind of created this and started the internet as we know it. There's something you'll learn about the history of it somewhere along the way. Actually, next week. Next week or the week after that, it's gonna be in this class. But the anchor tag is links to another thing. The big idea that took off networks built for a while, and the big idea that showed up in 1990, the invention of World Wide Web as we know it, is instead of sending you the data, because that can often be very, very large, how about if I just tell you where to go get the data? So I'm going to add, that's what we use the anchor tag to. So anchor these words to another spot on the network, or the internet in particular. And to do that, we use what's called a hyperlink reference, which again is all abbreviated. So href, and I'll go to https:// That means protocol. :/ anytime you see that, that's how you tell the computer to run the protocol that is typed right before it. In case you've never heard what that meant, I'll just go to google.com. I'll just go to some random website. So now when I run this, notice it turned blue and underlined. I think everybody here knows how to recognize the link. So I'm going to click that. It should jump over to another page. Why did that? A new tab. There we go. If I open it in a new tab, it jumps back to this is a sandbox environment, so it wasn't connected to the internet at large. Just a little sandbox to isolate and try things. So if I right click, it opens up in another tab, and that's the idea. Instead of sending you the data, I'll just send you the location of the data, because the location is going to be a lot smaller, so it transmits quicker and it's a lot easier and it formats nicer. Just for a quick example, but still it goes with those little tags. And then what's really nice about this is it says what type of data we have. Talked about that type stuff a little last week with databases. Gives us the metadata. In particular, this data is going to connect to google.com. So that's another way to get to our search engine now. Have the actual data. And then we have the point, say where that data stops, the end of the data. A really good form for going through the computer. And when it goes into the computer, there's some background stuff about HTML in particular that is really, really good for a computer. You create a tree, just one of the better shapes, and then browsers usually modify that tree into the best way for a computer to process the data. But that's background stuff. Not necessarily a point for an introduction class. But those are what your two assignments will be. You'll make a little Python code and some HTML. You can do both right here. And again, you don't have to download the download button is right over here. Notice the or ellipsis, the download button's under that. Or since there's several files together, CSS is cascading style sheet. That's how we say what color it's going to be and stuff. So like maybe I want to say the anchor is going to be have a background color of green. And change so that's how we set the style. And JavaScript is where we do stuff dynamically. Kind of what we were just doing in Python a moment ago. The store variable, do some math, run through a selection structure, do a loop. So we do that stuff 15 times, then that happens in the JavaScript. So we have several languages we mix together here. And again, you don't necessarily have to download the files. If you want to, you can download them all into a zip folder and send that to me. Or if you do it here, you can just come over to invite and copy that link and send that link to me. And I can view it on here. That can be a little bit easier than, I guess it saves a step. Instead of downloading, uploading the file, and you just grab that and copy and paste that link right into the submission spot. Not a difficult step it saves, but that's probably the easier way when I go to grade it too, because I can quickly get there from any machine, no matter which machine I'm on, what's blocked or whatever. The internet is probably allowed on that machine. Hopefully it'll be kind of fun when you do that. Some of us really enjoy programming. When I see a program run, I get the same feeling as when I play a song, grab an instrument, write a song, or pull up paints and paint a picture. That creative artistic aspect. That's how I feel about software development. It's art, the creation thing. I find it really relaxing and enjoyable. So hopefully you'll have fun with that assignment and enjoy it. Enjoy what you're doing. Give it a try. No matter where you're heading in IT, you will need the ability to feed instructions into a machine. So you want to get some, that's where you're going to practice that, even if you're not going to do anything with software development pathway after this class. Actually, you will. Everybody has to take SDEP 1.1. So you do have to take one software development class. So you'll have to do something. So after that class, even if you're never going to do anything with software development or a lot of programming, you'll still do occasional small scripts or even single instructions in your terminal. Which terminal and or hotkeys were my recommendation for that foundational skills. Try to do something new. And when you turn that in, just tell me what you did, how you did it. There's always more. So no matter how good you currently are with the computer, there's a new way you could do that. You can do that in a Python script. You already know a lot about it. You got to do a Python assignment this week. Have Python make those files and directories for you. Lots of different alternatives. Try to learn something new with it. We're in a learning environment. Terminal and hotkeys would be my recommendation, because those will pay off down your IT education pathway. Anybody have any questions about stuff from today? See head shaking no here. I'll give it a few seconds. So people on the Zoom call can have time to reach the mute button. Okay, I assume 5 seconds of silence means no questions. If you have any, let me know. Otherwise, you all have a great day, and I will see you on Thursday.